Hello students, look at the question. X into 1 minus x square dy plus 2x square y minus 5x square into dx equal to 0. Okay, so let us try to get dy by dx so that we can identify the type of the differential equation. So divide by dx, then x into 1 minus x square dy by dx plus 2x square y minus 5x square equal to 0, and x into 1 minus x square dy by dx. Here we can make this group into two group, then multiply y 2x square minus 1 into y, the remaining term to the other side 5x square. Okay, so we can convert this differential equation into linear differential equation of the first type. What is the first type? dy by dx and y term on side and term independent of y on the other side. So once again we can divide by x into 1 minus x square throughout the differential equation. Then we can get dy by dx plus 2x square by minus 1 by x into 1 minus x square and y, and 5x square by x into root of 1 minus x square. Okay, so this is standard form is taken as 1. The coefficient of y is p, is q. So to convert the differential equation into an exact differential equation, we have to multiply by integral factor. So for that, what is integral factor? Exponential of integral of the coefficient of y with respect to x. X is independent variable here. Then integral of p dx, integral of 2x square minus 1 by x into 1 minus x square, or by partial fraction, and we can have three fractions, x into 1 minus x into and 1 plus x. So ABC, or because of the 1 minus x square here, we can do some adjustment, minus of 1 minus x square minus x square by x into 1 minus x square and dx. So minus into 1, minus 1, minus x square and minus x square minus 2x square into minus 2x square. So we need this kind of adjustment to integrate. Now we can separate 1 minus x square by 1 minus x square, so minus dx by x, minus dx by x, then minus or minus plus, and x square by x, x by 1 minus x square dx. So this is minus log x plus 1 by 2 log of 1 minus x square, then log of root of 1 minus x square minus log x, that is log of root of 1 minus x square by x. Okay, so this is integral of p dx. What is integral factor? We have to take exponential, that is e power integral of p dx. Integral factor e power integral of p dx is equal to root of 1 minus x square by x. So okay, if we multiply equation 1 in the integral factor, the left side is d by dx of the dependent variable y into integral factor, y into integral factor, the other side q into, what is q? The whole thing, and 5x square by x into root of 1 minus x square into integral factor. So in order to remove d by dx factor, we have to integrate. So after integration, y into integral factor can be taken now, and root of 1 minus x square by x, root of 1 minus x square by x, then integral of 5x square by x into root of 1 minus x square, integral factor root of 1 minus x square by x dx. You can cancel, and x square dx, x square, only 5 dx. Okay, and go through it. Then finally, and y in the root of 1 minus x square by x, x into x square, everything cancel, 5 x with an arbitrary constant. So this is the general solution of the differential equation given, and go through it. We'll go to the next question. The next question, cos square x into dy by dx minus tan 2x y is equal to cos power 4x. So we can divide the given differential equation by the coefficient cos square x to convert into linear differential equation. Then dy by dx minus tan 2x, so divided by cos square x into y equal to cos square x. Okay, this is the first type of linear differential equation, dy by dx minus, and the whole thing including minus tan 2x cos square x is p, py equal to q. So integral factor, this known factor, e power integral of p dx, here p equal to minus tan 2x upon cos square x. So integral of p with respect to dx minus the tan 2x 2 tan x by 1 minus tan square x, 1 by cos square x secant square x dx. So minus 2t by 1 minus t square, the whole thing dt, since I have taken t as tan x. Then minus 2t is the derivative of log of 1 minus t square. So derivative of 1 minus t square, this is of the form f dash by f. So integral f dash by f log mod of f mod of 1 minus t square with the integral constant, then log mod of 1 minus, what is t? T is tan x, tan square x. So that the integral factor equal to, without the constant factor and e power log identity function, so 1 minus tan square x. So this is integral factor, 1 minus tan square x. Now what to do? You can take this is standard form and the standard equation into integral factor. Equation 1 into integral factor. What the result in differential equation? D by dx of y in the integral factor is q in the integral factor because of the exact nature of the differential equation. After integration, y in the integral factor 1 minus tan square x integral of q on q cos square x, cos square x, the integral factor 1 minus tan square x dx. Then cos square x into 1 cos square x, cos square x into tan square x sin square x. Okay, why? Tan square x is sin square by cos square, sin square by cos square into cos square cancelled, sin square. This is familiar trigonometric identity. This can be written as cos 2x. Then integral of cos 2x sin 2x by 2 with an arbitrary constant. then left side y into 1 minus tan and square x. So this is considered a general solution of the differential equation cos square x divided by dx minus tan 2x into y is equal to cos power 4x, and go through it. The next question, 1 plus y square dx equal to tan inverse x minus y dy. One additional condition given. What is the indication of the additional condition? Once along with the differential equation any other condition given mean we are supposed to give particular solution or singular solution instead of general solution. What is the meaning of the condition? Y of 0 equal to 0 mean when x equal to 0 y will take the value 0. This is nothing but y equal to 0 when x equal to 0, it should be applied at the end of the solution of the differential equation. So once only apply the condition on general solution to get the value of arbitrary constant c. Okay, now look at this 1 plus y square, and there are two terms y related term, only one term x related term in. So it can be written as a not dy by dx, dx by dy, dx by and dy. So dx by dy, what will come? Tan inverse of x minus y by 1 plus y square, or dy by dx, and go through it. So what the question, we need little correction. This is not, previously it was tan inverse of x, there y, not. So actual question tan inverse of y minus x. Okay, make note of the correction. Now, so number of y terms 2, number of x term 1 mean, we can write straight away the second type of linear differential equation, dx by dy plus px equal to q. To convert the given differential equation this form, directly divide by 1 plus y square into dy. So divide by 1 plus y square into dy. Then dx by dy is equal to tan inverse of y by 1 plus y square minus x by 1 plus y square. After rearrangement, dx by dy plus x by 1 plus y square, the other side tan inverse of y by 1 plus y square. This is standard form of this type. So integral factor e power integral of p dy, because y is the independent variable, not pdx, make note of it. Then integral of p dy is integral of dy by 1 plus y square is tan inverse of y plus c. Then integral factor e power tan inverse y. Okay, no need the arbitrary constant, it will not make any difference because this is a factor, term by term it will multiply. Okay, now equation 1 into integral factor d by dy of x into integral factor is equal to q in the integral factor. After integration, x into e power tan inverse of y, this is integral factor. What is q? Tan inverse y by 1 plus y square. Tan inverse y by 1 plus y square into e power tan inverse y and dy. So dear student, if you take and u equal to tan inverse y, what will happen? Du is dy by 1 plus y square. So x into e power tan inverse y equal to this, tan inverse y equal to u e power u du. apply integral by parts is e power u into u minus 1 with the integral constant. Then x into e power tan inverse y, e power and tan inverse y into tan inverse y minus 1. So this is general solution. What is the question? We have to give particular integral or singular solution when x equal to 0, y equal to 0. So take y equal to 0 when x equal to 0. X equal to 0 on the left side completely 0, and tan inverse 0 e power 0 1 into 0 minus 1 plus c. So this implies c equal to 1. Then singular solution, final answer. Singular solution x into e power tan inverse y equal to e power tan inverse y of tan inverse y minus 1 plus 1. This is the value of arbitrary constant, and this is singular solution or one particular member of the family of function related to the given and differential equations. Thank you, students.